Hello guys, so today I'll be solving this problem. This is count negative numbers in a sorted matrix. So the problem states that we have been given m cross n matrix grid, which is sorted in non-decreasing order, which means in non-increasing, which means like all the elements and rows are sorted in decreasing order. Okay. Okay, which means like all my rows will be in some in this nature rows, as well as if I go vertically, which is like column wise, they will also be in decreasing order. Okay, then we need to return the number of negative numbers in the grid. So it's a pretty easy problem. So if you look at the constraint, like my m and n, basically the number of rows and the columns are in the range of 1 to 100, which basically means like we can go for a big O of n square approach. Okay, which means like iterating over iterating over all the rows and columns. Okay, by using a two nested for loop for row in rows, or to be precise, like 0 to number of rows I have, then number of columns I have. If I simply iterate over them and I check whether grid of row and column, if it is less than 0, okay, I can increment my answer. Okay, so this approach will work. Okay, and with this we will have a time complexity of number of rows times number of columns, and if I put the max values, this is like big O of 10 to the power 2 times 10 to the power 2. Okay, so it's basically like 10 to the power 4 operations we will be doing, which is great, we can do that. Okay, but the problem challenges us to do it in a big O of number of rows plus number of columns solution. Okay, so yeah, how to do that? So so with this approach we are not using this thing which we have been given, like the rows and the columns are sorted in non decreasing order. Okay, so we can leverage this information to reduce the time complexity more. So the idea is, so we'll be doing a staircase kind of approach. Okay, so if I plot if I put this example, okay, so this is what 4 3 2 minus 1, then I have 3 2 1 and minus 1, then I have 1 1 minus 1 and minus 2, then I have minus 1 minus 1 minus 2 and minus 3. Okay, so yeah, so these are my columns 0 1 2 3, and these are my rows 0 1 2 3. Okay, cool. Now if we observe here, okay, so we have a minus 1 here. Okay, if this guy is minus 1, okay, and since my rows are sorted in decreasing order, which means for this value, okay, all of the values to the like all the following values in the same column, okay, will be lesser than this, which means they will be negative itself, right? So I can, if I know this guy is negative, then I don't need to see these people, right? Okay, similarly what I need to check is, okay, I'll put a pointer here. Okay, let's call it call pointer. Okay, call pointer. Okay, then for every row, okay, I will use this pointer to calculate how many negative elements I have. Okay, now how this pointer will work is, for every row I will iterate backwards. Okay, why backwards? Because I know if I go backwards my value will be increasing, right? Cool, which means there is a chance that I will meet a positive number. Okay, so the idea here is I will iterate row by row. Okay, let's say there is a row pointer. Okay, um, now for every row, okay, I will use this call pointer to move backward. Okay, why I'm moving backward? Because once I found a negative number, okay, that means I don't need to look at any value in the same column. Okay, I just need to check whether the neighboring column, okay, is a negative number. If that is also a negative number, then also I can skip all the values to the bottom of it. Okay, by doing so, okay, so let's take this example only. Okay, so I have minus 1 here. Okay, and there is only one value. Okay, what I will be doing is, for this current row I'll update my answer to 1. okay, plus equal to 1, okay, and I will shift my pointer to here, okay. Then in my next iteration for the row, okay, which will be at this, okay, my pointer will start from here, okay. Now this value is not positive, like not negative, okay, which means since in my previous iteration I have seen a negative number, okay, which is this value, okay, and currently my pointer is here. Since this value is negative and the rows are the columns are sorted in decreasing manner as well as my row, okay, whatever value this is, if this guy is not negative, okay, which means whatever value to the right of it, okay, those will be negative because I have gotten a negative number in my past. So yeah, that's the idea. So yeah, that's the idea. So in my next iteration of this row, okay, my pointer will be here. Then uh, when I am here, I can see I have already a negative guy here, okay. I will update my answer to 1 plus 1, okay. Then I will shift my pointer to the down itself because this guy is not negative, okay. Once I'm finding a negative number, I'm jumping backwards, okay. Cool. Now in this row iteration, my pointer will start from here. Now cool, this is a negative number. What I will do is I will shift my pointer to here, to this place, okay. Now this guy is not negative, which means whatever values to the right of it, those will be negative, okay. So yeah, here I'll add plus 2, okay. Then after this row evaluation, then I will shift my row pointer to here and my call pointer will be starting here only, okay. Now in this row, okay, I can see, okay, I have found a negative number. I'll shift my pointer to here, okay. Then I'll see again I'm finding a negative number. I'll shift my pointer to, like, basically this will violate my boundary rule because after 0 this pointer will go to -1, okay. Call will become -1, okay. Now what I will do is, so how I am looking, like how many numbers to the right of a number are like negative, that's my claim, right? Because as you can see, when I was at here, I was claiming that whatever number to the right of it, okay, those are negative uh, because of this decreasing trend. So yeah, here I am uh, basically shifting towards, like, shifting before 0, okay. My values become negative. So what I will do is the number of elements to the right of this, okay, that I can simply count by the number of columns I have minus wherever my pointer is pointing, which is call, okay, and I will do a -1, okay. So here if I see the number of columns I have is 4, okay. Now my call is pointing to here, okay, and this will become minus of -1, okay. Then I have a -1 here, okay. Now this -1, this -1 will cancel themselves and I will get 4 as my answer. And as you can see, there are exactly 4 elements which are negatives, okay. I will add a +4. Now if I sum them up, okay, this will be 1 plus 1 2, 2 plus 2 4, and 4 plus 4 8, okay, and 8 is my answer. So now if you look, okay, I'm not touching every element, like I'm not touching all element, okay. Basically I'm shifting my rows, and every time I'm finding a negative number, I'm shifting my columns so that I don't have to iterate over those columns again, okay. So at max I can say that my call pointer, okay, will be shifting uh, number of columns time, and my row pointer will shift, like I'm doing this iteration, will be rows time, okay. And at max I will be touching rows plus calls element because I'm traversing diagonally, okay. So that's the case. So yeah, at max I'll be touching elements, number of rows plus number of columns time. So this will give me a time complexity of big O of number of rows plus number of columns I have, okay. And with this space complexity, okay, I do not have any so basically I'm working with pointers, so those are like constant space time, okay. So basically I'll be using some variables. So yeah, I'll won't be using any space, so constant space. So yeah, that's the idea. You don't have to touch every element. You can use the decreasing information that is given in the question and simply move your pointers for calculation. So yeah, that's the idea. I'll be quickly implementing in Rust. Okay, so yeah, first thing first, I'll be capturing the number of rows I have, so that will be rows grid len. Then I'll capture the number of columns I have, which is grid of 0 of len. Okay, then I'll create my answer variable and I will initialize to i32 because I need to return i32. Cool. Then I will initialize a call pointer. Okay, I'll say let call. This will be 0, but I will initialize. This will be calls minus 1 because I will be starting from the end of my first row. Okay, calls minus 1, and I'll make this as a i32 variable because as you can see, like my call can become negative, so it won't be a usize variable. So yeah, I'll be initializing as a i32 variable. Cool. Then I'll create my row pointer, which is simply a pointer in my for loop. So for row in range 0 to number of rows I have. Okay, then I will run a while loop. I'll say while call is more than 0, more than equal to 0, and my current grid value is negative. Okay, I'll keep on shifting my call pointer backwards. Okay, so yeah, I will keep on decreasing my call pointer. Now at the end of this row iteration, once I found a positive number, this loop will break. Okay, so whatever my pointer position is with respect to that, I will calculate how many negative numbers I have found. So this that will be ans or plus equal to ans calls, number of columns I have wherever my call pointer is pointing, and a minus 1. Okay, and yeah, that's all. My row pointer will keep on updating the row value and my call pointer basically running backwards. So yeah, that's the thing. Now my call is initialized as i32. Now this calls thing is in usize, so I'll simply convert this to i32. So yeah, cool. So yeah, we don't have postfix operations, so this will be minus 1, minus equal to 1. Cool. And yeah, this is i32. It need to be usize, so I'll say usize. And voila. Okay, it passed the initial test case. Now if I submit, and it got accepted. So yeah, that's the thing. So here we are not touching all the elements in the grid. So if we are touching all the elements, then that will give a time complexity of this. Okay, here we are moving in a staircase fashion because if you look at our iteration, my call is somewhere here. Okay, then it shifted to the same place. Okay, but in my next row, okay, it shifted 2 places. Okay, then in the final row iteration, my call shifted to the like to before or like less than 0 value. Okay, so you can see like it is forming a staircase structure. That's why we call it a staircase approach. So yeah, that's the idea. Now as you can see, like we are at max this staircase length if you observe. Okay, so that is basically the number of columns. Okay, and the height of this staircase is basically the number of rows I have. Okay, so because of that, my time complexity will be rows plus the number of columns. So yeah, cool. Now I'll quickly show you the code for C++. So it's pretty similar to what we did in Rust. So yeah, so here also I'm initializing rows and columns that I have and my answer variable. Then I'm using 2 while loops. Okay, here I can also change it to a for loop. So for int row equal to 0, row less than rows, and row plus plus. Okay, and I will simply need my call pointer. Okay, cool. So my row pointer I have, it's basically iterating over all the rows. Then I have this while loop which is basically running my call pointer backwards again. And yeah, at the end of every row iteration, I'm basically updating my answer, and I'm doing this row plus plus which I needed in the while loop. Now for the for loop I don't need it, so simply delete. And yeah, after that I'm returning my answer. Now if I run it for all initial test cases, it passed. Now if I submit, and it got accepted. Cool. Now let's do it for Golang. For Golang also you can see pretty similar to our C++ and Rust approach. So here also I'm initializing rows and calls, then my answer variable, then I'm initializing my row pointer and call pointer. Okay, I can do the same stuff here also that I did for C++. So I can initialize my row pointer here itself. So and I'll say row plus plus, and I only need my call pointer, which is calls minus 1. Cool. So yeah, after that I don't need this row plus plus because here I'm increasing it. Cool. Now in Golang we do not have a while loop, so in the for loop itself I'm checking whether my current call pointer is more than or equal to 0. If that's the case, then check if the grid value is negative. If it is, then move backwards. Okay, now once you have stopped, okay, then update your answer with respect to the call position that you have. Okay, how many elements to the right of your call pointer are negative. So yeah, that's the idea. Now if I run for all initial test cases, it passed. Now if I submit, it got accepted. So yeah, that's the solution, and we have successfully solved this challenge also, n plus m time complexity. So yeah, that's the approach. I hope you like the explanation. If you do, please do subscribe to the channel and put a like in the video if you really like the solution. So yeah, that's the concept, and you are still okay if you are doing it in an n square approach because the number of operation is what, 10 to the power 4, so you are good. Okay, but if you are in an interview and the interview says is to like say you to do this, then you have to do this staircase approach, which is pretty simple. Like simply draw it out in a white paper and you will observe this staircase pattern, so you just need to move your pointer. So yeah, cool. So that's all for today's problem. Just stay tuned to watch more LeetCode random solution in my playlist. So yeah, thanks for watching. Bye bye.